Objectives: to design and construct the tallest and strongest structure that is able to stand on its own using the prescribed materials. Materials: scratch paper, long/short-sized bond paper, as many as you can. 1 meter long masking tape. Assigned members: for the civil engineers are Dane Geraint Mucho and Horde Daryl Alcaza. For the material engineer is Justine Anbinas. For the theoretical engineer is Shane Botines. For the construction engineer is Jessette Nicole Cortez. For the structural engineer is still Jessette Nicole Cortez. For the mechanical engineering is J. Claudette Duro. And lastly, for the disaster risk and documentation is Adrian James Dollett. Materials: papers. It used to make our tallest and strongest structure. The papers are combined to make the structure stronger. We doubled layers of the papers so it can withstand the wind. Masking tape. It is used to bond and support the bond paper structure to prevent it from separating, and also to ensure that all the bond papers in the structure are securely attached. Civil: wind is one of the most important factors that architects and engineers must consider when designing tall structures. While skyscrapers might appear to be highly strengthened and immovable structures, all tall buildings are designed with a high degree of flexibility in mind. This is principally due to the impact of the wind forces known as wind loads have on the structure as it becomes taller. While you might be experiencing a pleasant breeze at street level, the force of the wind generally grows as you go higher, so created our design similar to the Toronto CN Tower. Our structure is 20 inches in length while it's 2 inches in diameter, while the 4 triangle sides of the structure which serves as the support of the body is 7 inches in height and 5 inches in its base. Theoretical: the foundation of the structure main purpose is to support the weight of the structure. It also transmits and distributes total load of the structure to a larger area of support, to provide stability to the structure and to prevent differential settlement of the structure. Likewise, the foundation isn't just holding the house up, it also acts as a stabilizer to prevent lateral movement, that is, movement from side to side. Like storms, rains, high winds, and other inclement weather conditions that can batter a building from one side or another. Then, balance that creates a state of equilibrium, the condition of a system when neither its state of motion nor its internal energy state tends to change with time. A simple mechanical body is said to be in equilibrium if it experiences neither linear acceleration nor angular acceleration. Unless it is disturbed by an outside force, it will continue in that condition indefinitely. For a single particle, equilibrium arises if the vector sum of all forces acting upon the particle is 0. A rigid body is considered to be in equilibrium if, in addition to the states listed for the particle above, the vector sum of all torques acting on the body equals 0 so that its state of rotational motion remains constant. An equilibrium is said to be stable if small, externally induced displacements from that state produce forces that tend to oppose the displacement and return the body or particle to the equilibrium state. Mechanical, as you can see in the testing of how strong our structure is, the structure that we made is strong enough to deal with the wind. It's because we used cartolina and scratch papers for it to be thick, and we rolled it tightly to make sure that the structure will stand really strong and tall on its own. We also put 4 triangular papers attached to each side of the rolled paper that will serve as its foundation so that it will not fall, though it's not tape on the ground.